Today our lesson is about Pythagorean Theorem. On the front here we have a Lego representation of the Pythagorean Theorem being proved. We have a 3 square, a 4 square, and a 5 square, and it represents our Pythagorean Theorem. The Pythagorean Theorem states a squared plus b squared equals c squared. So if we take A and B are considered the legs of a right triangle, and C represents the hypotenuse. Oops, running out of room. Okay, C is always directly across from the right angle, and that is always your longest side, where A and B are not. They make up the right angle. So A makes up the right angle, B makes up the right angle. We looked at Pythagorean Theorem previously when we had worked with distance. So now I'm going to identify my parts. I have 3 and 9. Those are my legs. And my x, that's the hypotenuse. So that means that I'm going to be solving for C in my equation a squared plus b squared equals c squared. So 3 and 9 are going to go in for my legs. So 3 squared plus 9 squared equals c squared, or we can put in x. And then we're going to square it. So 3 squared is 9. 9 squared is 81. And that's going to equal c squared. And that's going to give me 90 equals c squared. Then I have to get rid of c squared, and the opposite of squaring something is to take the square root. So I'm going to take the square root, and I get square root of 90 is equal to c. We learned how to simplify that, so I'm going to take 90 and I'm going to divide by 2 since it's an even number, and I get 45. I can't divide by 2 anymore, but I can divide by 3. And that's going to give me 15. I can divide by 3 again. That gives me 5. I can divide by 5. And that gives me my 1 and done. Then I circle my pairs. So I do have a pair of 3s. And 3 gets to come out and play. 2 and 5 don't have partners. They don't get to come out and play. They have to stay inside. And they get multiplied back together. So my final answer for C is going to be 3 square root of 10. 3 square root of 10. That is my simplified answer for the Pythagorean theorem for problem number 1. Number 8 here asked me to tell whether or not this is a right triangle. Well, the Pythagorean theorem only works if it's a right triangle. So I'm going to plug that in to see if my numbers come out to the Pythagorean theorem. Now, how do I know which numbers go where? Well, I'm looking for the biggest one, 12, because that should be my hypotenuse. The largest number should be the hypotenuse. So that means 7 squared plus 10 squared should equal 12 squared. So 7 squared is 49, 10 squared is 100, and 12 squared is 144. And I'm going to add 49 and 100. I get 149, and I need to see if that equals 144. And it does not. That means this is not a right triangle. It would be a right triangle if those two parts were actually equal. Let's talk about Pythagorean triples. A Pythagorean triple is a set of positive integers, a, b, and c, that fits the rule a squared plus b squared equals c squared. Here's a list of Pythagorean triples here in this table. The ones that are used the most, those are the ones that are pretty much right here in the top row. 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41. Those are the ones that are most commonly used, and these are the ones that you're going to see on your standardized test, your SAT, your ACT, your PSAT. They will use these over and over again. Now, one thing to remember too is if you take a 3, 4, 5 and you give it a multiple, like times 2, you get 6, 8, 10. Well, guess what? That's a Pythagorean triple as well. Okay, if I take 5, 12, 13, and I triple it, that gives me 15, 36, 39. That is also a Pythagorean triple. These are going to be used commonly whenever you're working with Pythagorean theorem, and they're worth learning. Okay, so here we need to find the missing side of our triangle. It is the hypotenuse, which means that 4 and 5 are the legs, and the hypotenuse is the part that I'm missing. So with a squared plus b squared equals c squared, 4 and 5 are going to go in for a and b. So I'm going to have 4 squared plus 5 squared equals c squared. 4 squared is 16. 5 squared is 25. That equals c squared. 16 plus 25, that equals 41. That equals c squared. And then I need to take the square root. And I get the square root of 41 is equal to c. I want to check and see if I can simplify it down. Can't divide by 2, can't divide by 3, can't divide by 5. 7 doesn't go in, 11 doesn't go in, 13 doesn't go in, and I'm pretty sure if I keep going, 41 is a prime number. So square root of 41 would be our final answer. And the question also asked, is it a Pythagorean triple? No, it is not a Pythagorean theorem, a triple. It is not a Pythagorean triple. Okay, it is not a multiple of any of the base ones that were on the previous slide, and it is not follow a squared plus b squared equals c squared. Okay, so our goal for problem number 21 here is to figure out what x is. And I'm going to point out this right triangle here that has a side of 9 and a side of 15. That side of 15 is the hypotenuse. I recognize that as a Pythagorean triple. Okay, I see the 3 times 3 gives me 9. 3 times 5 gives me 15. Okay, that is part of the 3, 4, 5 triangle, where here we have 3, here we have 4, here we have 5, and it's been multiplied by 3. So I can get that bottom leg by taking 3 times 4, and I get that this piece right here is 12. Well, if that piece there is 12, then that makes the piece on the left side 13, because 12 and 13 would add up to 25. Now I can find x. X is my hypotenuse. So I would have 9 squared plus 13 squared is equal to x squared. 9 squared is 81, 13 squared is 169, and that's going to equal x squared. And then I get 250 equals x squared. And of course we have to take the square root. So I get the square root of 250 is equal to x. However, we do still need to simplify it. So I'm going to come up over here. We have the square root of 250. I can divide by 2 because it is an even number, and I get 125. It's not even anymore, so I can't divide by 2. So 3 would be my next number. However, through my divisibility rules, 3 does not go into 125. My next number is 5. 5 goes into 125 5 times. 25 times. That can go in there another 5. I get 5 left over. I can go in another 5, and there's my 1, and I'm done. So I have a pair of 5s. That 5 gets to come out and play. I have a 2 and a 5 that don't have partners. They have to stay inside, and they get multiplied together. So 5 square root of 10 is going to be my x, and that will be my final answer, 5 square root of 10.